I just completed and calibrated both the charge controller on the right and the low voltage disconnect on the left, and I tested everything. It seems to be working, and let me tell you, it hasn't been easy interconnecting all those wires, but so far everything it's okay. Nothing has burned yet. Oh, for the little story, I'm going to tell you that later. I managed to burn an inverter. It was a 75 watt inverter, the one I had in the previous video. I forgot to disconnect all the batteries, and I had 4 batteries connected at the same time, and the consequences that I had, basically the inverter explode. Well, for right now, let me focus on those 2 pieces of equipment. The first one is the low voltage disconnect. I'm standing on the side because the blue light is so bright that I can't stand in front. See, I found those 2 boxes. I believe it used to be amplifiers, or I don't really know what it was, but I managed to put my 2 boards inside, the LVD right here and the charge controller on this side. Let me tell you that the LVD actually is the one feeding the inverter that you see on the floor. The inverter is a 700 watt inverter with let's say 2400 peak, and I have my 4 batteries interconnected. The batteries are 7 amps hour each, 12 volts, 7 amps hour each, and that's what I use, and that's my inverter, 700 watt. I had everything wired to this and I have on one side the charge controller and the other side the low voltage disconnect. Both of them are on right now, and it shows a voltage, a battery voltage of 12.91. I will definitely say it's going to be 12.91 plus or minus 0.03 volts. That means it's going to be 12.94, between 12.94 and 11.8 volts. Oh, sorry, 12.94 and 11.88 volts. I'm messing up. 12.94 and 12.88 volts. That's correct now. Wow. Those 3 MOSFETs are the one driving the inverter, because they are driving and checking whether or not the battery has the correct voltage, is at the correct voltage level. If not, this LED turns off. I'm going to do a test later. You will see when I launch my inverter, I turn my inverter on, the LED is going to turn off to show that the battery has been drained down to 12. I believe I calibrated it to be off at 12.6, and the charge controller will disconnect and connect everything to the dump load if the voltage is above 13.8 volts. Wow, As you can see, everything seems to be working okay. I would like to put schematics of my connection, my interconnections online, so that whoever wants can actually use them. I will do that later, but for right now, I'm happy everything worked. And let me show you how I managed to put together my dump load. I used a computer alimentation box that I transformed to put my resistors inside. So my resistors are right in there, and I'm going to use this ventilation system to push the hot air outside out the box. And I have my first dump load, which is 4 resistors, and the second dump load, another 4 resistors, and that's the connection for the ventilation, 12 volts for ventilation. And I haven't connected it yet, but they're supposed, for each dump load, they're supposed to be interconnected right here. I label everything right here for the first dump load, and it's right there for the second. Well, I think I said pretty much everything. The next step would be to put my windmill outside at the beach and try to see whether or not it will be charging the battery fast enough for the inverter to discharge it. I'm not really dreaming. I know that it's not going to work because my windmill needs to be improved. And also I'm thinking about adding solar panels to it later, because this whole system can actually handle both of them, the windmill and the solar panel. Let me stop right here, and I really appreciate criticism. I really appreciate people writing to me about how to change the whole system, how to improve it, and I respond individually to each of them. Thank you again for following my thread, and see you next time.